Let f be the function whose graph is shown on the right. Find the following limits. The first limit here, the limit as x approaches -3 from the left of f of x. I'm going to use black ink over here on the graph to show what's going on with that. So here is -3 for x on the graph. And we are going to approach -3 from the left, as indicated by this subtraction sign in the exponent. So that means numbers that are less than -3. So if you follow the graph from the left of -3, it looks like that graph, the y values of that graph are headed down to -infinity. So now we're going to take a look at that same x value, -3. We're just going to come at it from the right, as indicated by the plus sign over here. So I'm going to do that one in orange. If you come at that graph from the right, you can see that the y values will increase without bound all the way up to +infinity. Now this last one, where we approach -3 from the left and from the right, we have already done all the work. We're just trying to see what happens at -3. So we've checked the left-hand limit, got -infinity. We checked the right-hand limit and got +infinity. The limit for f of x as x approaches 3 does not exist. And that's because these two values do not match. So similarly, in purple, if you come over here to the other side of the graph at 2, and you travel along the graph, it looks like the y values go to -infinity. And if you go to the right side of 2, as indicated by this plus sign, the y values, somewhat red, there we go, the y values also go down to -infinity. And this sixth limit down here in blue, this is the limit as x approaches 2 from both sides of f of x. So similarly, we're checking the left-sided and right-sided limit, and this time they match. So we can call this limit -infinity. The very last limit down here in black, that's asking you to find the limit as x approaches 3. And that's coming from the left and from the right. So it's trying to close in on that y value right there. That y value is -1. So this answer is -1.